Hello people, today we are going to learn about the infinite limits. So let's get started. What are infinite limit? When the limit of function fx does not exist and fx goes to positive infinity or negative infinity, then we call that an infinite limit. Let's see an example to understand this. Let's check the behavior of this function fx is equal to 1 by x minus 1 as x approaches 1. So using tabular method, we just take points which are close to 1 on both sides of 1. So here, as we put these values, we see that as x goes closer to 1, from left fx is smaller and smaller, because as the negative number increases, it becomes smaller and smaller. So as the x goes closer to 1 from the right, from this side, fx is bigger and bigger because this is positive number. So as the absolute value increases, the actual value increases. So as it approaches from right, it becomes bigger and bigger, and as it approaches from left, it becomes smaller and smaller. So that means for as it approaches from left, it goes to minus infinity, and as it approaches from right, it goes to infinity. So the we see that these two are going to in different direction and are not equal. So what we can say is that limit of 1 by x minus 1 as x approaches to 1 does not exist. Even if we use the substitution method, if we put 1 is 1 minus 1 is 0. So 1 divided by 0 is infinite. So it is 1 by 0 is not indeterminate form. So we can say that as x approaches to 1, the limit does not exist for this particular function. So let's see the behavior of this function, which says x squared plus x minus 2 divided by x squared minus 1 at 1 and minus 1. So using 1 and putting the value as close to on both sides, on the left hand side and the right hand side for x, and then using that particular value of x to calculate this function's value, we will make the table for both 1 and minus 1. Here we see that in case of plus 1, first we do not directly put in case if you want to use the substitution method, you first need to factor it. So when factoring it, you will see that you will get, for the top function, you will see that you will get x minus 1 multiplied by x. Let's multiply and see what we get. Let's factor it. For x square, this is the function, where is it? So the function is x square plus x minus 2. So when we factor it, we get this. X square plus 2x minus x minus 2. We get x minus 1 divided by x plus 2. So x minus 1 here divided by x minus 1 multiplied by x plus 2, whole thing divided by, it says x square minus 1. So x square minus 1 can be written as x minus 1 multiplied by x plus 1. What happened? Here multiplied by x plus 1. So this one x minus 1, this x minus 1 and this x minus 1 gets cancelled. So the answer you get is x plus 2 divided by x minus 1. So when you try to put the values here, x plus 2 divided by x plus 1, you put the value 1 here for positive 1, you get the value 1.5. How? Let's see. When you put 1 in place of x, this becomes equal to 1 plus 2 divided by 1 plus 1 is 2. So 3 by 2, which is equal to 1.5. So this is what you get. So for using substitution method, you get the limit as it approaches, x approaches to 1, the value of the function is 1.5 for this particular thing, tabular method. And for the second value, that is as x approaches minus 1, we again use tabular method or substitution method. When you use substitution method, if you put minus 1 in the denominator, that is 1 minus 1 here, this x minus 1 thing will become 0. So denominator is going to be 0, which is again indeterminate form. So as x approaches minus 1, the limit for this function does not exist. Remember, always for calculating using the substitution method, you must first factor it and cancel the equal thing from the numerator and denominator, and then calculate the value using the substitution. Because if you don't factor it and you just try to put the values, you see that x square minus 1, if you put 1 here, the denominator becomes 0. So this becomes not indeterminate or not defined thing. So you must factor it to the smallest value and then substitute the value to get the result. So for this particular function, for x, the limit x is equal to 1. As x approaches to 1, the limit exists. But as x approaches to minus 1, the limit for this function does not exist. Using tabular method also, as x approaches to 1 minus, that is less than 1, then the limit is minus infinity. As x approaches to 1 plus, that is to the positive side, the limit is infinity. So both the limits are not equal, so limit does not exist. Let's see the behavior of this function, x squared plus 2 3x. Using the tabular method, you can substitute the values of x to get the values. Or if you don't want to use the tabular method, as x goes to closer to 2 from left, fx is bigger and bigger. So here you can see that here as x approaches to 2, the value of the function is bigger and bigger. And as x approaches closer to 2 from the right, from this side, again the fx become bigger and bigger, which is close to infinity. So on the both sides we see that it is near to infinity. So the answer is, as the limit of the function as x approaches to 2 is infinity. So infinity means it is not defined, or infinity, there is no value, it's indeterminate form. So if you use substitution method also, if you put 2 here, 2 minus 2, this cannot be factored. So this is the lowest factor it has, this function has. Just substitute 2 in place of x. 2 minus 2 is 0. So anytime the denominator is 0, it's indeterminate form. So the first theorem is, if fx is equal to nx divided by dx is a rational function where dc is equal to 0 and nc is not equal to 0, then the line x is equal to c is vertical asymptote of the graph f. So let's see an example to understand more. This is the function given where we see that dc equal to 0. So first we try to factor it, and we see that if we factor it, it becomes x minus 3 divided by x minus 3 multiplied by x minus 1. So x minus 3 gets cancelled, and we get final value we get is x minus 1. So if we put in the denominator, that is dc equal to 0, that means let's put x minus 1 equal to 0 and then calculate the value of x. So x is equal to 1. So at x is equal to 1, we get the vertical asymptote of fx. So you can try this at your home. Function is equal to x plus 2 divided by x square minus 1. If you try to factor it, still it remains the same. So just equate the denominator to 0 as it says here, dc equal to 0. So denominator equal to 0, x square is equal to x square minus 1 equal to 0. So x square will be equal to 1, which will give you x equal to plus or minus of 1. So there are two vertical asymptote for this function, minus 1 and 1. So let's see the theorem 2. Limit of power function at infinity. If p is a positive real number and k is any real constant, then limit of k divided by xp equal to 0 as x approaches to minus infinity. The second is k divided by xp equal to 0 as x approaches to infinity. Then third is k multiplied by xp as x approaches to minus infinity will be equal to plus or minus of infinity. And again limit of k multiplied by x raised to power p as x approaches to infinity will be plus or minus of infinity. Provided that x raised to power p is a real number for negative values of x, the limit is 3 and 4 will be either minus infinity or infinity depending on k and p. So let's see example to understand this theorem. So first example is fx is equal to 5 by x square. As limit approaches to x approaches to infinity, the value is 0. That we already know. If we put anything divided by infinity is equal to 0. So the first answer is 0. And even if it is minus infinity, if we put minus infinity in place of x, it is again 0, as we all know. And for in case of multiplication, 5 multiplied by x cube, anything multiplied with infinity is infinity, so this proves this. Anything multiplied with minus infinity is minus infinity. So minus 2 multiplied by x raised to power 4. So even if this is an even power, so if you put minus infinity in place of x, this minus will make it minus infinity. Limit of polynomial function at infinity. This is the theorem number 3. This is the polynomial where n is greater than equal to 1. Then the limit of p of x, that is limit of polynomial as x approaches to infinity, will be limit as x approaches to infinity a n x n equal to plus or minus of infinity. Similarly for negative infinity, the same thing will be there. Each limit will be either minus infinity or infinity depending upon the a, n and n, the value of n. So let's see an example. 4x5 minus 3x raised to power 4 plus 1 is the function. The limit x approaches to infinity. So when you replace the replace the x with infinity, we see that anything multiplied by infinity is infinity, minus infinity plus 1 is again infinity. So this is the polynomial. You don't need to evaluate each and everything. You just need to evaluate the term with the highest power of x as per the theorem. The highest power of power is x raised to power 5 multiplied by 4. So we just evaluate this and we get the infinity. In the second example, we again use the first term of the function polynomial because it has the highest power of x, which is 7. So just putting the value of minus infinity uh, um, in place of x raised to power 7, and obviously we get minus infinity. Since this is the odd power, so minus infinity multiplied 7 times will give you minus infinity. It doesn't become positive. If this was even power, then it would have become positive. Since this is odd, so it is minus negative infinity. This is the fourth theorem, limit of rational function at infinity and horizontal asymptote of rational functions. So function fx, which has a numerator polynomial and denominator polynomial, where am is not equal to 0 and bn is equal to 0. Then The limit of function x as x goes to infinity, approaches to infinity, will be the first term with highest power uh, for uh, for both numerator and denominator. You just calculate the first term. Taking the first term of both numerator and denominator, calculate the limit for this function by substitution method and you'll get the answer. So similarly for negative infinity. There are three possible cases for these limits. If m is less than n, then limit of fx limit of x as it approaches to infinity or minus infinity is equal to 0. So that means if the power of the numerator is less than the power of denominator, then it becomes 0. If the power of numerator is equal to denominator, then it is line y is equal to am by bn. Just remove the variable, just put the coefficient, and that becomes the horizontal asymptote for that function. And if the power of x is greater for numerator than the numerator, then it becomes minus infinity or infinity depending on the power, which is mn, or the values of the coefficient am or bn. And fx does not have horizontal asymptote because it will be infinity or minus infinity. So let's see an example. So here we have to find the horizontal asymptote. As we saw that we just use the first term with the highest power for both numerator and denominator to calculate the horizontal asymptote. So for calculating the limit, we just take the first term for both numerator and denominator, 7x raised to power 4 divided by 6x raised to power 5. Then we see that the denominator has higher power, so we cancel the rest of the x. Then it finally becomes 7 by 6x. So putting the infinity in the denominator, obviously anything divided by infinity is 0. So y is equal to 0 is the horizontal asymptote for this particular function. For next one, we see that the second term has the highest power. So we just take the second term with their signs, that is negative of 3 x raised to power 3, 4x raised to power 3. Both the powers get cancelled, so just the coefficient remains. So minus 3 by 4 is the horizontal asymptote. That is y is equal to minus 3 by 4 is the answer for a horizontal asymptote. So in this one, we see that 4x raised to power 7 has the highest power, so we keep it like that, use it. And then the second, in the denominator, the highest power has 6x raised to power 4. This term has the highest power, so we put it like this. And then we cancel the common term and we find that the 7 minus 4 is 3, so numerator has x raised to power 3 and multiply by 4 by 6, and obviously anything multiplied with infinity becomes infinity, so there is no horizontal asymptote for this function. Here we see that x divided by 4 minus x. According to theorem, we have to use the highest power of x. Highest power of x is the 1. So just take x and minus x. We always take it with the sign, positive or negative sign, whatever we have. So x divided by minus x, x get cancelled. We get minus 1. Limit is x as tends to minus infinity is always minus 1 because this is a constant term. So y is equal to minus 1 is the horizontal asymptote. So guys, I hope you got some idea on infinite limit and practice to more of the examples. You can use these examples without looking at the solutions and practice on your own and match the results. So I hope you got some idea on infinite limit and horizontal and vertical asymptote. Come back to my channel or subscribe to my channel for more videos on limit and other tutorial on maths. Thank you very much for watching. See you soon.